Close your eyes for a moment and picture the night sky. Stars scattered like whispers of fire, galaxies like faint rivers of light. Yet, hidden among this calm are places where the universe folds in on itself, swallowing even light into a silence so deep it almost feels alive. These are black holes. Strange, invisible giants waiting at the edge of our imagination. But what if they are not just graves of stars? What if hidden in their darkness lies a doorway? A gateway not only through space, but perhaps through time, or even into another universe altogether. A quiet night sky and the mystery of invisible giants. The night sky has always been a stage where humanity rehearses its questions. We gaze upward, seeing beauty, yet sensing something unseen lingers behind the glow of stars. Astronomers notice that galaxies seem to move as if something heavy, something invisible, sat in their centers. This weight was not seen, only felt, like an unseen presence in a quiet room. Black holes announce themselves not by light, but by the way they bent the behavior of everything around them. Imagine staring at a patch of sky that looks utterly empty. To the eye, nothing exists there, yet stars near that region dance strangely pulled by a hidden force. It is like watching trees bend without wind. You know something powerful is passing, but it remains unseen. This invisibility makes black holes more haunting than the brightest star. They hide in plain sight, their silence more telling than 1,000 suns burning. When scientists realized such giants exist, it reshaped our place in the cosmos. A star could live for billions of years, yet under the right conditions collapse into something smaller than an atom and heavier than a mountain. What began as a flame ends as a shadow, deeper than night. This contradiction, light giving way to infinite darkness, draws us closer to their mystery. There's a strange comfort in knowing that something so powerful exists silently above us. We may never see it directly, but the universe has written its existence in the patterns of stars. The quiet night sky is not as still as it seems. It is alive with hidden giants shaping the fate of galaxies. And that thought makes every glance upward feel like a secret shared with the universe. Perhaps the mystery of black holes is less about science and more about our longing. We sense there is more to reality than what the eye can capture. We lean into the silence, listening, hoping that these invisible giants might reveal not just the universe's secrets, but also something hidden within ourselves, the strange hunger of collapsed stars. A black hole begins as a star's tragedy. When a massive star burns its last breath, it no longer has the strength to hold itself up. Its own gravity turns against it, pulling inward, crushing matter into a state beyond imagination. What remains is hunger. Gravity so strong it pulls in everything nearby. Even the star's light, the very fire that once defined it, is consumed. It is like watching a king stripped of his crown, only to rise again as an unseen ruler of shadows. This hunger is relentless. Unlike a flame that flickers out, a black hole feeds endlessly. Gas clouds, nearby stars, even unlucky planets, everything becomes food for its invisible appetite. And as it devours, it doesn't simply vanish. Instead, matter is stretched, twisted, and funneled into an abyss where the rules of physics begin to blur. To imagine falling into one is to imagine being pulled into infinity itself. Scientists once thought of black holes as simple endings, but the more we watched, the stranger they became. The hunger isn't just destructive, it shapes galaxies. Without them, many galaxies might never form. Their appetite organizes the cosmos like gardeners pruning branches to let others grow. Creation and destruction are intertwined, hidden inside the black hole's invisible grip. If you stood close enough, you would see light itself spiral downward, wrapping around the hole like water around a drain. The closer it gets, the faster it spins, glowing in one last desperate blaze before being swallowed. The black hole doesn't just eat, it stages a spectacle of light and energy at its edges, a strange beauty born from hunger. And so the black hole becomes a paradox. Born from collapse, it becomes the architect of new cosmic order. Its hunger, instead of being the end, may actually be the beginning of something else. And if hunger itself can reshape the universe, we must ask, what lies beyond its feeding shadow? Gravity's endless pull towards silence. Gravity is the most patient sculptor in the cosmos. It works slowly, invisibly, yet with absolute certainty. In the case of black holes, gravity doesn't just hold, it dominates, it pulls without pause. And once something crosses too close, there is no return. This pull is not violent in appearance, it is silent, unhurried, inevitable. Imagine walking across a plain of ice, feeling the ground tilt beneath your feet, pulling you toward a hidden well you cannot see. Near a black hole, this pull is stretched across space itself. Time slows, light bends, matter stretches like taffy in a process scientists poetically call spaghettification. It sounds strange, almost whimsical, but it reveals how utterly alien gravity behaves when it grows too strong. Even the strongest metal, the brightest flame, the fastest particle, all would be torn into a thin line like handwriting unraveling into the void. Yet this silence isn't empty. It holds stories. The pull of a black hole can guide entire stars, shaping the spirals of galaxies. It is as if the universe places these hidden anchors to choreograph the grand dance of light. Without their pull, the stage of the night sky might never look the way it does. Silence, in this sense, becomes the most powerful sound of all. There's a haunting thought here. Gravity does not rush, yet it always wins. Over time, everything moves toward it. Whole galaxies drift, stars spiral, planets wander. And in the end, black holes remind us of this truth. No matter how bright or strong, nothing escapes the gentle persistence of gravity's call. It is less a scream, more a whisper that waits patiently for billions of years. As we picture this silent pull, we begin to feel its strange poetry. The black hole is not just a monster devouring light, it is gravity's masterpiece, a reminder that even silence has weight, and even absence can shape existence. And perhaps within that silence, a hidden passage waits, where light itself cannot escape. Light has always been our most faithful companion. It travels across the universe, carrying stories of stars, galaxies, and cosmic history. Yet, at the edge of a black hole, even light loses its freedom. The pull of gravity there is so absolute that photons, the smallest particles of light, are bent into paths that can never escape. To stand near such a place is to watch light itself surrender. Imagine a beam of light traveling for billions of years, carrying the memory of a star's birth. As it approaches a black hole, it curves, bends, and then vanishes. Not because it has been destroyed, but because it has been trapped. The event horizon becomes its prison, a boundary where escape is impossible. To look at a black hole is to look at the place where light itself has drawn its final line. This is why black holes appear black. They are not objects glowing with fire, but regions where all stories of light are silenced. What we see is not the hole itself, but the absence it creates, the shadow it casts against the glowing matter swirling around it. It is an outline drawn not in ink, but in the silence of stolen light. And yet, there is a strange beauty in this. Around the edge, light that almost escapes forms rings, shimmering halos called accretion disks. These glowing crowns make black holes paradoxically visible, shown not by their presence, but by the way they bend light into art. In 2019, when humanity captured the first image of such a halo, it was like photographing the edge of the unknowable. Light failing to escape does not mean the story ends. It means the story is being rewritten inside the black hole. What happens there is beyond our reach. And that is perhaps the most intriguing part of all, because when light itself cannot tell us what lies beyond, our imagination takes over. The veil of the event horizon. The event horizon is often called the point of no return. It is not a surface you can touch, but a boundary drawn by gravity. Once something crosses it, the rest of the universe will never see it again. To the outside world, time seems to stop at this veil. An object falling in would appear frozen forever, fading slowly until it vanishes. The horizon becomes both a stage curtain and a tombstone. This veil is strange because it challenges our sense of reality. From the outside, we think nothing ever passes it. Yet from the perspective of the object falling in, crossing is seamless. Time continues normally, and the fall feels swift. Two truths exist at once. An object is both frozen and falling. It is as though reality itself is split by the horizon. The event horizon is also a paradox of knowledge. It hides what lies within, but it also defines the black hole itself. Without it, we would not know the boundary existed. It is a silence that reveals by concealing. And this silence pulls us closer, not to answers, but to deeper questions. If we could stand just outside, we would feel space stretched and time slowed. We might watch a star fall for eternity, its final light smeared thin across the sky. To witness this would be to watch reality unravel like thread pulled from a cloth. The veil is less about endings and more about transitions, where one version of reality becomes another. And so the event horizon may not just be a prison wall. It may be a doorway, a threshold that once crossed, no message returns from. But thresholds are rarely just barriers, they are also entrances. What if beyond this veil lies not just darkness, but another path altogether? Listening to the universe's deepest whispers. Black holes do not shout, they whisper, and those whispers travel as ripples in space-time, gravitational waves. When two black holes collide, they send out tremors that wash across the cosmos. These waves were only recently detected, like faint echoes of a drumbeat struck billions of years ago. To listen to them is to hear the universe remembering its own story. It's strange to think the silence of black holes is not silence at all, but a low hum like the breathing of the cosmos itself. Each detection of these waves tells us something new. We learn the size of the black holes, the violence of their collision, and the distance at which the event unfolded. It's like eavesdropping on a conversation between giants, one that carries across unimaginable distances, and yet when we hear it on Earth, it arrives softer than the rustling of leaves. The universe hides its loudest events inside its quietest songs. When we think of sound, we think of air carrying vibrations, but gravitational waves do not need air. They ripple through the very fabric of space. To detect them, scientists built instruments so precise they can measure shifts smaller than the width of a proton. Machines built by human hands are now listening to whispers that began billions of years before our species existed. This thought lingers. If we can hear the universe in this way, what else might it be saying? Could black holes be broadcasting messages not in words but in waves? Each ripple might be a clue to understanding whether they are merely prisons of gravity or something more, perhaps even gateways. For a moment, silence becomes language, and listening becomes discovery. And it leaves us with a haunting idea. Maybe the deepest truths of existence are not shouted. Maybe they are whispered, waiting for someone patient enough to hear them. Time bending near the edge of darkness. Close to a black hole, time itself begins to twist. Einstein's theory of relativity told us that gravity bends time just as it bends space. Near Earth, this effect is small. Your watch ticks a tiny fraction slower on the ground than on a mountaintop. But near a black hole, the effect is extreme. To hover close to its edge is to step into another kind of clock, one that runs slower than the universe around it. Imagine two twins, one far away, one daring to orbit close to the black hole. For the one far away, decades may pass. For the one circling the darkness, only moments might tick by. When they reunite, they are no longer the same age. This is not science fiction. It is science's prediction, confirmed again and again through experiments with time and gravity. Black holes are not just holes in space, they are holes in time itself. The closer you drift toward the event horizon, the slower your time runs. To an outside observer, you appear frozen, yet to you, moments flow as normal. This dual truth unsettles us because it reveals how fragile our sense of now really is. There is no single time. There are many, stitched together by the fabric of space itself. The bending of time makes black holes more than cosmic monsters. They become laboratories where reality behaves differently. If time slows to near stillness, then could crossing into a black hole be like stepping into eternity? Could this slowing be a hint that time is not ending, but opening into something we do not yet understand? And if black holes bend time so profoundly, then what happens beyond the veil might not be destruction, it might be transformation. Perhaps time inside flows in ways no human mind can imagine, a river branching endlessly into futures we cannot see, falling forever into the unknown. What would it feel like to fall into a black hole? The question has haunted thinkers for centuries. The truth is stranger than imagination. As you cross the event horizon, you would feel no sudden shift. You would simply keep falling, pulled ever inward. To you, the journey would feel normal. To anyone watching, you would appear to freeze at the edge, never quite entering. Two realities coexisting, separated by perspective. This fall is endless. There is no stopping point inside. The pull is constant, unbroken, like sliding down a slope with no bottom. Space itself is curved so sharply that every path leads inward. You cannot climb back because there is no up anymore, only down. And yet you do not crash into a wall or floor. You simply fall deeper and deeper into a silence without end. Some scientists suggest you would be stretched thin, atom by the tidal forces inside, but others wonder if the rules of physics change before that happens. Perhaps the fall continues not into destruction, but into another region of space, or even another universe. Falling into a black hole might not be an ending, but the beginning of a passage. To imagine this fall is to confront fear and wonder together. It is terrifying because it strips away control, yet beautiful because it may carry you into the unknown, like drifting in a dream where gravity itself becomes the guide. You cannot resist, you can only surrender. And perhaps that is why black holes captivate us. They are not just objects to study, they are experiences to imagine. Falling forever into a silence that might turn out not to be silence at all, but the opening of a hidden door, the slowing of clocks in cosmic shadow. One of the strangest features near a black hole is the way clocks behave. Not just mechanical clocks, but all processes that measure time, heartbeat, thought, even the flicker of light. To an observer watching from far away, every clock near the black hole ticks slower. A spaceship descending toward the event horizon would seem to freeze, its signals stretched longer and longer, like echoes fading into eternity. This stretching of time is not an illusion, it is real. The deeper you go, the more the universe outside seems to race ahead. If you hovered just above the horizon, you might watch stars being born, galaxies colliding, civilizations rising and falling, all in the span of your own short minutes. A lifetime could pass for you, while billions of years sweep by beyond your reach. For those outside, though, you never truly fall in. You remain forever at the edge, slowed until you vanish from sight. This paradox of time both flowing and standing still turns the black hole into a mirror of perspective. It shows us that reality is not a single story, but depends on where you stand and how you measure. This makes black holes a stage for one of the most haunting possibilities. They could be natural time machines, not in the way science fiction imagines, but in the way relativity already proves. To enter their shadow is to enter a different rhythm of existence. To look upon them is to see time itself distorted into shapes we cannot yet draw. And so when we think of black holes as gateways, perhaps we should not only think of them leading elsewhere in space. Perhaps they are gateways in time. Thresholds where past, present, and future lose their usual order, and something entirely new begins to emerge. Space stretched thin by an unseen hand. Near a black hole, space itself is not what we know. It stretches, warps, and bends as though pulled by invisible hands. Distances no longer behave as we expect. A journey that seems short from one perspective may become infinite from another. It is as if the universe's fabric is twisted into knots, and black holes are the places where those knots tighten beyond undoing. To picture this, imagine a trampoline with a heavy weight pressing down its center. The surface dips, curving deeply. Now imagine that weight pressing so far it tears through, leaving a tunnel. This is how physicists often describe space around a black hole, a curve so sharp it becomes a hole, leading, we know, not where. The unseen hand of gravity does not just bend, it punctures. This stretching reshapes the fate of everything nearby. Stars can be caught in orbits that defy prediction. Light can circle endlessly around the edge, never escaping. Space itself becomes elastic, capable of trapping even the fastest travelers. Black holes become less like objects, more like places where space changes its rules entirely. The unseen hand also suggests something daring. If space can stretch, maybe it can connect. A stretched fabric sometimes tears, sometimes folds. Could black holes be places where the fabric folds so tightly it meets itself again? Could what looks like a trap in one universe be a doorway to another? And here, at this thought, the black hole ceases to be only destruction. It becomes a possibility, a gateway not in myth, but in physics, an opening written into the very stretch of space itself, waiting for us to wonder what lies beyond. The singularity hidden at the core, at the very heart of a black hole lies the singularity, a place where our mathematics breaks down. Here, density is thought to be infinite, and the fabric of space and time folds into a single, unmeasurable point. It is like reaching the bottom of a well, only to find no bottom exists, just a collapse into nothingness. Scientists call it a singularity, not because they fully understand it, but because they don't. It is a word marking the edge of knowledge, a placeholder for mystery. To stand before such an idea is unsettling. Everything we know, atoms, particles, forces, becomes irrelevant at this core. The laws of physics, so reliable in daily life, simply stop applying. What does it mean for something to have infinite density? Can matter truly be squeezed into nothing? Or is it our language that fails us, struggling to describe something that defies all categories? Some believe the singularity is not real, but a clue, a hint that our theories are incomplete. Perhaps when we finally merge quantum physics with gravity, the singularity will dissolve into something more understandable, A knot in the fabric, yes, but not an impossibility, just an invitation to look deeper. Others imagine the singularity as a seed. Instead of ending all things, it could be a place where new universes are born. What looks like collapse from our perspective might look like expansion from another. A singularity here could be a big bang somewhere else. In this way, black holes might be cradles of creation, disguised as tombs. And so, the singularity at the core of a black hole may not be the end of the story. It may be the beginning of another, a story we cannot yet read, but which the universe continues to write in silence. Matter crushed beyond recognition. As matter falls into a black hole, it doesn't simply disappear, it is transformed. Atoms that once held together are pulled apart. The very building blocks of reality are stretched, heated, and compressed to unimaginable extremes. A planet, a star, even light itself, all reduced to fragments that no longer resemble what they once were. In the black hole's embrace, identity itself is stripped away. This crushing is not violent in the way we imagine explosions. It is slower, deeper, stranger. A star can spiral inward for millions of years, shedding layers of gas, spinning faster as it nears the horizon. The final fall is quiet, invisible, yet absolute. To us, the star is gone. To the black hole, it has simply been folded into its endless archive. Scientists try to model this process, but the numbers grow wild. Temperatures rise to billions of degrees. Pressures exceed anything we can replicate on Earth. Even subatomic particles may be ripped into forms we have never seen. What black holes create inside them is not destruction, but a transformation into the unknown. Some theories suggest matter never truly vanishes, only changes form. Information about what falls in may remain, imprinted in subtle patterns at the horizon. If so, then nothing is ever truly lost, only rearranged beyond recognition. The black hole may be less of a grave, more of a chrysalis. And perhaps that is the most haunting idea, that everything falling into a black hole is not destroyed, but reborn as something new, hidden from our eyes, but still a part of the universe's memory. The idea of infinite density. Infinite density is a phrase that stops the mind. What does it mean for something to be infinitely dense? Imagine all the mountains of Earth compressed into a grain of sand. Now imagine that grain shrinking smaller, smaller still, until it has no size at all, yet still carries all the weight. That is the singularity, density without volume, weight without space. It is an idea that both terrifies and fascinates. In physics, infinity usually signals a limit of understanding. Our equations, stretched too far, begin to break. Perhaps infinite density is not literal, but the universe's way of telling us we need a new language. Somewhere between quantum mechanics and relativity lies the truth, waiting to be written in equations we do not yet have. Some dreamers take the idea further. If a black hole compresses everything into an infinitely dense point, maybe that point is unstable, maybe it erupts, exploding outward into a new cosmos. Could our own universe have been born from the singularity of a black hole in another? Infinity then becomes less about an ending and more about a bridge between worlds. The concept also forces us to think differently about limits. If density can grow without bound, what does that mean to the universe? Are black holes infinite wells in a finite cosmos? Or are they keys showing us how something finite can open into the endless? Each possibility leaves us with more wonder than certainty. And so, infinite density remains not just a scientific puzzle, but a meditation. It asks us to accept that reality might be stranger than thought, larger than mathematics, and deeper than imagination. Questions no telescope can answer. Even with our most powerful telescopes, black holes resist our gaze. We can photograph their shadows, measure their pull, and detect their whispers, but what lies inside remains hidden. This is not because of distance, but because of the nature of black holes themselves. No light escapes, no signal returns. They are mysteries protected by silence, questions guarded by cosmic walls. Astronomers can watch stars dance around an invisible center and know something is there. They can see jets of energy burst from galaxies powered by unseen engines. They can measure time stretching, space bending, and light curving, but none of these tell us what it truly feels like beyond the horizon. Observation has its limits, and black holes live precisely at those limits. This makes them more than scientific objects. They become mirrors of our own curiosity. We can describe their edges in exquisite detail, but when we ask, "What's inside?" silence is the only reply. And yet that silence is not empty. It is the most tantalizing answer of all. Perhaps that is why black holes inspire not just science, but stories. They force us to fill in the gaps with imagination. Are they tunnels? Are they seeds of new worlds? Or are they prisons, holding matter forever in invisible chains? Until we find a new way of seeing, these questions remain locked inside the horizon. And maybe that is the role black holes play, not to give us answers, but to remind us that mystery itself has value. That wonder is not the absence of knowledge, but the beginning of discovery. Theories drawn from equations and dreams. When reality hides, theory takes its place. Physicists write equations, spinning possibilities that reach where telescopes cannot. Some theories are bold, imagining wormholes and bridges between universes. Others are cautious, refining the details of relativity and quantum physics. And in between lies a strange truth. Theories are as much about imagination as they are about mathematics. They are dreams written in symbols, waiting for proof. Einstein himself doubted black holes could exist, though his equations predicted them. Later, Hawking expanded the picture, showing how they could emit faint radiation. Each leap came not from observation first, but from daring to follow the math into unfamiliar territory. Theories often precede sight, like lanterns carried ahead into the dark. And yet, theory is never enough. It must meet reality. When the first image of a black hole's shadow was captured, it was like seeing a dream come alive. What was once pure theory now had a face, but even then the theories kept growing, because each answer opens more questions, and each equation whispers of unseen doors. Some imagine theories as scaffolds, fragile structures helping us reach higher floors. They are not the building itself, but without them we would never climb. Black holes test these scaffolds, bending them, breaking them, forcing us to rebuild stronger. In this way they are teachers, shaping not just our knowledge, but the way we seek knowledge. And so when we speak of theories, we are really speaking of human imagination reaching for the stars, for every equation is, at its heart, a dream. And dreams, when paired with curiosity, may one day show us what lies beyond the black hole's silent veil. Wormholes as bridges across the cosmos. Among the boldest ideas in physics is the wormhole. Imagine space as a sheet of paper. If you draw 2 points far apart, the distance looks vast. But if you fold the paper and touch the points together, the journey between them becomes instant. A wormhole is that fold, a tunnel connecting 2 distant regions of space created by bending reality itself. Some physicists wonder if black holes could be entrances to such tunnels. The equations of relativity allow wormholes to exist. They appear in solutions like strange side notes hidden in the math. But whether nature builds them is another story. Wormholes would be unstable, collapsing almost as soon as they formed. Yet the possibility remains. Black holes, with their extreme gravity, might be nature's attempt at creating such shortcuts. To imagine walking into a wormhole is to imagine leaving the familiar rules of distance behind. A trip across thousands of light years might take only moments. Galaxies separated by eons could be neighbors through a hidden bridge. Black holes, often feared as destroyers, may instead be gateways waiting to be crossed. And here lies the wonder: the same doorway that consumes light might also open. Pathways light could never take on its own. Black holes could be both endings and beginnings, collapses and corridors. Wormholes remind us that sometimes what looks like a prison might actually be a passage. If black holes do guard such tunnels, then the universe may be far more connected than we imagine. Space would no longer be a vast ocean, it would be a woven net full of secret doorways tying distant shores together. The possibility of shortcuts through space. Traveling through the stars has always seemed impossible, even at the speed of light. Reaching our nearest neighboring galaxy would take millions of years. But if black holes hide wormholes, then shortcuts may exist, tunnels that ignore the long journey and connect us directly. Suddenly the impossible becomes a quiet possibility, hidden in the folds of space itself. The idea is not just fantasy, mathematics suggests it, and stories, science fiction tales, have long dreamed of starships entering black holes and reappearing somewhere else. While unproven, these tales keep our imagination alive. After all, today's science was yesterday's story. Could wormhole travel be one of those dreams that eventually finds reality? The danger, of course, is instability. A shortcut might collapse the moment you enter, crushing anything inside. Some theories say exotic matter, strange forms of energy with negative weight, might be needed to keep the tunnel open. Exotic matter is hypothetical, yet its mere mention hints at how much more the universe may be hiding. Still, the thought lingers. If shortcuts exist, perhaps the cosmos is not as unreachable as it seems. Perhaps civilizations beyond our sight have already discovered such doorways, moving between galaxies in ways we cannot yet imagine. Black holes may not just shape galaxies, they may be cosmic train stations. And the possibility of shortcuts forces us to see black holes not only as dangers, but as opportunities. Perhaps the universe is far less about distance and far more about connection, waiting for us to find the keys. Tunnels connecting distant galaxies. When we look at the night sky, galaxies appear scattered and separate. Each one is an island of stars, adrift in an endless sea. But if black holes can create wormholes, then maybe these islands are connected by hidden tunnels. What looks distant to our eyes may, through such corridors, be right next door. Galaxies could be less isolated than we believe. Some scientists suggest that supermassive black holes, those anchoring entire galaxies, might be the entrances to such tunnels. Their enormous size could make them stable enough to form bridges across the universe. Imagine if the glowing core of a galaxy is not only a heart of gravity, but also a doorway linking it to another galaxy far away. The thought changes everything. Instead of galaxies being lonely travelers, they may be nodes in a vast cosmic network, joined by unseen threads of spacetime. The universe might resemble not an ocean, but a web, a structure where everything is connected through pathways we cannot yet see. This vision reshapes our place in the cosmos. Instead of being isolated in the Milky Way, humanity might be standing near a door we have not learned to open, but one that could someday connect us to civilizations across the stars. The tunnels may already exist, waiting in silence. And so, the black hole becomes less of an endpoint, more of a crossroad. A hidden station where galaxies meet, where the boundaries of distance dissolve, and where the universe whispers of journeys yet to come. Energy twisting like a spiral staircase. Around black holes, matter does not fall straight in. Its spirals, drawn into a swirling dance before crossing the horizon. These spirals, called accretion disks, glow with incredible energy. Gas and dust spin faster and faster, heating to millions of degrees, shining brighter than entire galaxies. To watch this dance is to see energy twist like a cosmic staircase, winding ever inward toward the unseen. This spiral is not just beautiful, it is revealing. It shows us how black holes gather, transform, and release energy. Jets of light and particles often shoot outward, perpendicular to the disk, traveling across vast distances. Paradoxically, even as black holes consume, they also give back, shaping their galaxies with streams of energy born from their spirals. Scientists wonder if these spirals might hint at deeper processes. Could the twisting of energy around black holes be connected to the way wormholes might form? The spiral feels like a bridge, winding from the visible into the invisible, from the known into the unknown. It is as if the universe is sketching the path into the gateway with glowing light. And the spiral staircase invites us to imagine, what if falling into a black hole is not chaos, but a guided path, a descent marked by order and pattern? Perhaps the spiral is not just energy, it is a map, a hint that the journey inward has structure, not just destruction. Energy twisting, light bending, matter glowing. This spiral reminds us that even in the darkest places there is still design. A staircase leading somewhere, even if we do not yet know where it ends. Imagining exits into another universe. If black holes are doorways, then where do they lead? Some physicists dare to imagine they might be exits into other universes. The singularity, instead of being an end, could be the beginning of a new cosmos, expanding on the other side. In this vision, every black hole is a seed, planting new universes beyond our reach. This idea changes the way we see reality. Our universe, with all its galaxies and stars, may itself have been born from a black hole in another. Each universe giving birth to others, an endless chain of creation stretching beyond imagination. Black holes then become less like graves, more like wombs of infinity. Of course, this remains theory, beautiful, daring, unproven, yet the possibility lingers. If exits exist, then falling into a black hole may not mean vanishing, but beginning again in another world. What seems like death from one side might be birth from the other. Endings and beginnings are two sides of the same door. This vision gives black holes a dual identity. They are destroyers in our universe, swallowing stars, planets, even light. But in another universe, they may be creators, expanding space, birthing galaxies, igniting stars. The same doorway is both loss and renewal, silence and song. And so when we gaze at the night sky and wonder about black holes, perhaps we are not staring at tombs. Perhaps we are looking at the gates of creation itself, exits into places where the story of existence continues, forever unfolding. The dance between destruction and creation. Black holes are often described as destroyers, devouring stars and swallowing light. Yet, in their destruction, something new often emerges. The fall of matter creates bursts of energy that can ignite new stars, shape galaxies, and rearrange the cosmic order. It is a strange dance, one step into silence, another into birth. Where something ends, something else begins. Black holes teach us that destruction and creation are not opposites, but partners in the same dance. This paradox feels familiar. Forests burn, and from their ashes new life rises, rivers flood, and their waters leave behind fertile ground. The universe seems to echo this cycle everywhere, and black holes may be its most powerful example. What looks like pure ruin is also preparation for renewal. Around a black hole, spiraling matter radiates incredible light. Whole galaxies are lit by the glow of material being consumed. These bursts are so powerful that they can outshine billions of stars. And yet this radiance is born from collapse, from destruction. Light and darkness are not separate. They are woven together at the black hole's edge. This dance reminds us that balance is not always gentle. Sometimes balance is fierce, shaped by loss and creation entwined. To fear the black hole as only destruction is to miss its other face, the creative force that reshapes the universe, quietly writing the next chapter of existence. And so the black hole's dance becomes a lesson. What ends is never truly lost, and what begins is often hidden within endings. Destruction and creation are not enemies, but steps in the same cosmic rhythm. Could death of stars mean birth of doors? Every black hole begins with the death of a star. A giant burns through its fuel, collapses under its own weight, and disappears into darkness. Yet this death may not be the final note. Some scientists wonder, could the death of a star be the opening of a doorway? Instead of ending, the collapse may be a transition, a passage into something beyond. When a star collapses, its light fades, but its gravity grows. The star becomes less of an object and more of a doorway, reshaping space around it. What looks like silence may be the threshold to somewhere else. The star, in dying, creates a path the living universe cannot yet follow. This idea changes the way we see death itself. Instead of an ending, perhaps it is a transformation. The star's energy is not gone, it is folded into new patterns, new realities. If black holes are gateways, then every star that dies may be opening a door to another world. Even here on Earth, endings often carry beginnings. A chapter closes in our lives, and though it hurts, it creates space for new growth. The cosmos seems to whisper the same truth through its stars. Death is not the end of the story. It may be the beginning of another. And so when we see the light of a star fade, we may not be watching silence. We may be witnessing the birth of a door, a secret passage carved in gravity, leading into the unknown, the particles escaping as mysterious radiation. For decades, black holes were thought to trap everything. Nothing could escape, not even light. But then Stephen Hawking suggested a daring idea. Black holes might not be completely black. They could slowly leak energy, releasing faint particles now called Hawking radiation. Even in their silence, they whisper tiny messages into the universe. This radiation is faint, almost impossible to detect, but its existence changes everything. It means black holes are not eternal prisons. They can slowly lose mass, slowly fade, eventually even vanish. Their permanence was an illusion. Like all things, they too are part of the cycle of birth and death. The particles escape not from inside the black hole, but from its edges where quantum effects twist reality. Space itself flickers with virtual particles, appearing and disappearing. Near the horizon, one particle may fall in while the other escapes. The black hole seems to pay a small price, shrinking with each whisper it sends out. In this way, silence is not absolute. It is broken by faint sparks. This discovery reshaped our understanding. Black holes are not only consumers, they also give back. They are not final walls, but participants in the exchange of energy that keeps the cosmos alive. Even the darkest objects must eventually return their borrowed matter to the universe. And so the idea of Hawking radiation transforms black holes from eternal endings into temporary doors. They do not only swallow, they also release, reminding us that nothing in the universe is ever truly lost forever. Hawking's voice in the cosmic silence. Stephen Hawking's contribution to black hole science was more than equations. It was a voice, daring to say the unthinkable, that even black holes cannot defy the laws of physics. In proposing Hawking radiation, he gave us a bridge between quantum mechanics and relativity, between the smallest particles and the largest cosmic giants. His work did not close the mystery of black holes, it deepened it. Hawking showed that black holes must obey thermodynamics, the rules of heat and energy. They have temperature, they radiate, they can eventually evaporate. This idea connected them to every other system in the universe. Instead of being strange outliers, they became part of the same laws that govern stars, oceans, even the warmth of our own bodies. But perhaps more powerful than his equations was his imagination. Hawking saw black holes not as cold, dead prisons, but as dynamic places where physics itself comes alive. His vision turned black holes into laboratories where the universe reveals its most guarded secrets. He invited us to wonder, to question, to dream beyond what we thought was possible. And though his life was filled with physical limitations, his mind soared into realms beyond stars. He reminded us that curiosity is more powerful than circumstance, and that even the most unreachable mysteries can be approached with patience and daring. His voice remains a guiding light in the silence of cosmic shadows. In every black hole we now study, Hawking's whisper is there, a reminder that silence is never truly silent, and mystery is never beyond reach. The slow evaporation of giants. If Hawking was right, then black holes do not last forever. Slowly, over unimaginable timescales, they leak radiation, losing mass bit by bit. For small black holes, this process is faster. For giant ones, it may take longer than the age of the universe. Yet eventually even the greatest giants fade, dissolving into the energy of empty space. The destroyers themselves are destined to be undone. This idea transforms how we see black holes. They are not eternal tombs, but temporary structures. They are part of the cosmic cycle, destined to vanish just as stars and galaxies vanish. The universe itself may one day be empty, silent, after the last black hole has evaporated into faint whispers of light. But even this ending carries beauty. The evaporation is not violent, it is slow, gentle, almost graceful. A giant that once consumed suns eventually returns its energy back into the cosmos. What it swallowed is released, not in the same form, but still present, still part of the eternal flow. The silence of a vanished black hole is simply another note in the universe's endless song. For us, it's hard to imagine such vast timescales. Our lives are brief sparks compared to the lifetimes of black holes. Yet to know that even giants fade is strangely comforting. Nothing, not even the most powerful, is immune to change. Everything flows, everything transforms, everything continues onward. And so the slow evaporation of giants reminds us that endings are never absolute. They are simply another way the universe teaches us that nothing lasts forever, yet nothing is ever truly gone. Information carried in faint signals. For years, scientists wondered, when something falls into a black hole, is its story lost forever? Hawking's theory of faint radiation suggested maybe not. Perhaps hidden in those whispers of energy are traces of the information about what was consumed. Like smoke carrying the memory of fire, these faint signals might hold the record of what once was. They are too subtle for us to read now, but they hint at a cosmic archive hidden in the silence. Every particle of matter carries information, its structure, its history, its unique signature. If black holes simply erased this, the laws of physics would be broken. Nature rarely breaks her own rules. Instead, many believe the information is scrambled, stretched, and encoded in ways we cannot yet decipher. The faint radiation becomes less of a glow and more of a language, an unread book written at the edge of the horizon. Imagine holding a letter written in invisible ink. You know the words are there, but you cannot yet reveal them. Black holes may be similar. The information may not be gone. It is simply hidden, written in a code beyond our current understanding. The faint signals escaping are clues waiting for us to learn the language of the cosmos itself. This idea reshapes the way we think of loss. What disappears into the black hole is not erased. It is transformed into a different kind of record, a record that demands patience, imagination, and new ways of seeing. In this way, the black hole becomes less of a thief and more of a scribe. And so when we listen to those faint signals, we are not just listening for particles, we are listening for stories, written in whispers, carried across the universe, reminding us that nothing is ever truly forgotten. The puzzle of what is lost and what remains. The question of black holes is also the question of memory. Do they erase the stories of the universe, or do they preserve them in ways we cannot yet see? This puzzle has divided scientists for decades. Some believe information is destroyed. Others believe it must remain woven into the horizon. The debate is not just about physics, it is about the very nature of reality. If information can be destroyed, then the universe is not predictable. The chain of cause and effect breaks. The past cannot be fully known. The future cannot be fully trusted. This strikes at the heart of science itself. Yet, if information is preserved, then black holes become guardians, keeping the secrets of the universe locked in silence until we learn how to read them. The puzzle deepens when we imagine falling in ourselves. Everything we are, our memories, our choices, our identity, would enter that darkness. Is it gone, erased without trace? Or does it remain, encoded in ways no human eye can yet perceive? The black hole becomes a mirror for our own fear of forgetting. Some theories suggest the event horizon itself stores information like a vast hologram wrapping around the black hole. In this vision, the surface is the book cover, holding every page of what has fallen in. Nothing is truly gone, it is simply written differently. This idea, called the holographic principle, suggests the entire universe may work the same way. And so the puzzle of black holes is also the puzzle of ourselves. What is lost? What remains? Perhaps the answer is that nothing is lost at all, only transformed into forms our minds cannot yet grasp. Memory of the universe etched in shadows. The night sky is a library of light. Every star we see carries its history across space, a message billions of years old. But black holes write their memory differently, not in shining light, but in shadows. Their presence is revealed in the way stars move, in the way light bends, in the faint whispers of radiation. The shadows themselves are records, etchings of memory, too deep for ordinary sight. When we look at a black hole's silhouette, we are not seeing absence, we are seeing history pressed into silence. The star that collapsed to form it, the matter that spiraled inward, the galaxies it shaped, all of these leave traces written in the black hole's shadow. It is not emptiness, it is memory drawn in negative space. This thought is haunting. It means that even darkness can carry history. Just as fossils in stone tell of ancient life, the silence of black holes may tell the story of cosmic ages. To learn to read these shadows may be to learn the hidden chapters of the universe's past. Scientists now use telescopes to capture these shadows, to measure their outlines with precision. Each ring of light, each curve of darkness is a clue. We are learning to read the language of shadows, to hear memory where there seems to be none. Black holes are not just mysterious, they are historians of the cosmos. And so when we gaze at the void, perhaps we should not see emptiness. Perhaps we should see the universe's memory etched in silence, waiting patiently to be understood. Black holes as cosmic librarians. What if black holes are not destroyers but keepers? Cosmic librarians guarding the information of everything that falls within. The matter may be transformed, but the record is preserved, locked inside the horizon like books sealed in a vault. To us, the library is silent, But silence does not mean emptiness, it means waiting for the right reader. This vision makes black holes less frightening. Instead of erasers, they are archivists. They gather, store, and protect. Each black hole becomes a vault of history, carrying the stories of stars, planets, and perhaps even civilizations that were pulled inside. Nothing is wasted, everything is shelved in the library of the cosmos. Imagine walking into a library so vast that the shelves stretch beyond sight. Every book is sealed, unreadable, yet you know each one contains a story. Black holes may be like that. The information is there, beyond our reach now, but waiting for the day when we learn how to open the covers. Knowledge is not lost, it is simply locked away. This idea brings comfort. If the universe values memory enough to preserve it, then nothing is ever truly forgotten. Black holes remind us that silence can be protective, that keeping is also a kind of giving. What is hidden is not erased, it is safeguarded for the future. And perhaps when we finally learn the key to this cosmic library, we will find not only the stories of stars, but also the answers to questions we have yet to ask. Books locked in invisible shelves. If black holes are cosmic librarians, then their shelves are invisible. We cannot see the books, cannot turn the pages, but we can sense the weight of the knowledge they hold. Each falling star, each burst of light swallowed, becomes a volume placed on these shelves. The shelves stretch across the universe, hidden, silent, and endless. The idea is both wondrous and frustrating. We stand outside the library, aware of its treasures, but unable to enter. Every telescope, every equation is an attempt to peer through the locked door. The universe has written its greatest secrets, but for now, we cannot read them. We are left only with the covers, the shadows, the hints. Yet, perhaps this is the point. A locked book is not useless. It inspires curiosity. It reminds us to keep searching, to invent new tools, to stretch our imagination further. Black holes with their invisible shelves challenge us to become better readers of the cosmos. In this way, they are teachers disguised as vaults. Their silence is not rejection, but encouragement. Each unanswered question is an invitation, each locked shelf a call to grow. The library of black holes is not closed forever. It is simply waiting until we learn how to open its doors. And so, as we drift to sleep under the stars, perhaps we can imagine the shelves of this hidden library, vast, silent, full of stories we have yet to hear. Waiting, as all books do, for the right reader to arrive. The link between quantum foam and gravity wells. At the smallest scales, the universe is restless. Space is not smooth. It flickers, bubbles, and shifts in what physicists call quantum foam. Tiny fluctuations pop in and out of existence, too small for our eyes, yet fundamental to reality. At the largest scales, black holes are the deepest gravity wells, bending space and time beyond recognition. The mystery lies in how these two extremes, foam and wells, are connected. Black holes may be the place where quantum foam meets cosmic gravity, where the smallest and largest scales shake hands. Quantum foam imagines space as alive with constant activity. Particles flicker into being, vanish, and reappear. In normal conditions, we hardly notice, but at the edge of a black hole, these fluctuations matter. The horizon is like a stage where quantum foam performs visibly, affecting how black holes radiate, how they lose energy, and perhaps how they connect to other regions of space. This connection tempts physicists with hope. If we can understand how quantum foam and black holes interact, we might finally unite the two great theories: quantum mechanics and general relativity. The smallest and largest pieces of the puzzle could lock together, revealing the picture of reality we've been missing for a century. In this way, black holes are not just cosmic mysteries, they are laboratories. Natural experiments where the universe itself shows us the rules we have yet to learn. The foam at their edge may be more important than the darkness at their core. The tiniest bubbles may hold the key to the biggest secrets. And so black holes whisper that reality is not divided. The smallest flickers and the largest shadows are woven together, part of one continuous story we are still learning to read. Tiny fluctuations birthing vast mysteries. The quantum foam that flickers at the smallest scales may seem insignificant, yet from these tiny fluctuations, vast mysteries are born. Imagine empty space suddenly producing a pair of particles, one falling into a black hole, the other escaping as radiation. This dance creates Hawking radiation, proof that the smallest flickers shape the fates of the largest giants. Tiny fluctuations ripple outward, carrying mysteries across billions of years. This is not unique to black holes. Quantum fluctuations are thought to have shaped the universe itself. In the earliest moments of the Big Bang, small ripples in the foam may have grown into galaxies, stars and planets. What begins as a flicker ends as entire worlds. The small is not separate from the large, it seeds it. When we think of the infinite vastness of space, it is easy to forget that it rests upon the smallest scales. Black holes remind us of this truth. Their horizons, shaped by quantum whispers, become monuments to the importance of the tiny. Even the most overwhelming silence may be sculpted by the faintest flicker. This is why quantum physics feels almost mystical. It suggests that what we call nothing is not empty. It is alive with potential, constantly creating. And black holes, with their hunger, amplify this process, making the invisible visible in faint signals we can measure. The vast mysteries of black holes are not built on strength alone. They are built on fragility, on fluctuations so small yet so constant that they create the stage upon which the universe plays its grandest act. Strings vibrating across invisible dimensions. Some scientists believe that the puzzle of black holes cannot be solved without a deeper theory, string theory. It imagines that at the smallest scales, particles are not points but vibrating strings. Their vibrations give rise to matter, forces, even gravity itself. If this is true, then black holes may not be singularities at all, but tangled knots of vibrating strings hidden in dimensions we cannot see. String theory also suggests the universe may have more than 3 dimensions of space, perhaps 9, perhaps more, curled up so tightly we do not notice them. Black holes might be gateways not only through space and time, but through these hidden dimensions. What looks like darkness in our world may be an opening into another folded layer of reality. This vision feels both strange and beautiful. Imagine plucking a violin string, its vibration filling a room with music. Now imagine cosmic strings vibrating across invisible dimensions, their music creating worlds, stars, and black holes. The singularity then becomes not an impossible infinity, but a place where strings vibrate beyond our comprehension. Some physicists suggest string theory could solve the problem of information loss. The information swallowed by black holes may not vanish, but be stored in the complex patterns of strings. What looks like disappearance in our 3 dimensions may simply be rearrangement in hidden ones. The black hole becomes less of a grave, more of a vault hidden in deeper space. And so strings remind us that reality may have more layers than we see. Black holes, far from being mysteries in isolation, may be the first doors into a universe woven from vibrations, songs, and dimensions unseen. The dream of uniting physics' 2 languages. For over a century, physics has spoken in 2 languages. One describes the large, planets, stars, galaxies, and gravity. The other describes the small, particles, atoms, quantum effects. Both are true, both precise, yet they refuse to speak to one another. Black holes may be the place where these two languages must finally meet. They are the crossroads where the rules of the very large and the very small collide. In relativity, a black hole is a smooth curve in spacetime, a geometry with elegance and inevitability. In quantum mechanics, it is a bubbling edge full of fluctuations, particles, and uncertainty. How can both be true? The dream of uniting these pictures drives the search for a theory of everything, a language in which both the small and the large can be described together. Black holes offer the stage for this union. Their horizons are both geometrical and quantum, both smooth and bubbling. To understand them is to force the two languages to finally reconcile. Every whisper of radiation, every curve of space is a clue that the separation of physics is only temporary. This dream is not just for scientists, it is for all of us. It reminds us that contradictions may not be conflicts, but invitations. The universe is not divided, it is one story told in different tongues. And black holes are the translators, forcing us to listen carefully until we learn the shared language. And so the dream of uniting physics is also the dream of uniting ourselves, of seeing that division is temporary, and that beyond contradictions lies a deeper harmony. Equations pointing toward hidden corridors. Equations are not just numbers, they are lanterns casting light into places we cannot go. Again and again, equations have hinted at hidden corridors in reality. Einstein's relativity pointed to wormholes, quantum theory pointed to Hawking radiation, string theory pointed to extra dimensions. The math seems to whisper of doors, even before we have the tools to open them. And black holes are where these corridors might lie. Sometimes equations predict things that feel impossible, like time slowing, light curving, or wormholes linking galaxies. At first, they seem like fantasy, but slowly observation proves them true. What began as strange symbols on paper becomes photographs, signals, discoveries. Equations are not fantasies, they are the universe's way of teaching us slowly. Black holes are full of such predictions. They are equations made real, corridors drawn in mathematics waiting to be discovered in the stars. Perhaps the paths they guard are not imaginary at all. Perhaps they are the very roots by which the universe connects itself, written in geometry we have yet to decode. This thought is humbling. We often think of math as human invention, but when equations predict the behavior of black holes, they reveal something larger. Math is not just ours, it is the language of the cosmos itself. We are not creating it, we are uncovering it. And so every time equations point toward hidden corridors, they invite us to follow. The corridors may be far beyond reach for now, but black holes stand as reminders that where the math leads, reality may eventually follow. Multiverse theories opening like petals. Some scientists believe our universe may not be alone. Instead, it could be one petal in a vast cosmic flower, each petal its own universe, expanding outward. Black holes, in this view, may be the stems that connect petals, linking one universe to another. When matter collapses into a black hole here, it may explode outward as a big bang somewhere else. Creation and destruction are simply two sides of the same unfolding flower. This vision is breathtaking. It means the cosmos may not be a single story, but a library of stories, each universe with its own rules, its own stars, its own paths of life. Black holes become the doorways between chapters, passages that connect books we cannot yet read. What looks like an ending here may be the birth of a universe beyond. Mathematics hints at this possibility. Solutions to Einstein's equations allow for multiple universes, and black holes fit neatly into the picture. They may not simply swallow, they may also birth. Each singularity could be a seed, and each seed could bloom into a cosmos. The multiverse becomes not just theory, but a natural extension of what black holes already do. The thought is humbling. Our universe, with its galaxies and suns and Earth, may be just one blossom among countless others. To fall into a black hole may be to step into another petal, to awaken in a reality with new colors, new laws, new beginnings. Infinity does not mean endless repetition, it means endless possibility. And so black holes remind us that reality may be larger than imagination. What we call the universe may simply be one petal, waiting in a flower that blooms forever. A doorway not to somewhere, but to many. If black holes are gateways, they may not lead to just one place. They may branch like rivers, offering not one path, but many. Imagine stepping through a doorway only to find yourself in a hall of doors, each leading to a different universe. Black holes could be such branching corridors, splitting reality into countless possibilities. The choice may not belong to us, but to the physics that governs the passage. This is where the idea of the multiverse deepens. Each black hole might not just connect universes, it might create variations. Different outcomes, different histories, different versions of events. One universe where a star is born, another where it collapses, another where it never formed at all. Black holes may be the switchboards of reality, routing possibility into existence. For us, this is more than theory. It is an invitation to wonder. If such doorways exist, then somewhere other versions of us may walk different paths, not just in imagination, but in physics. A black hole becomes not just a hole in space, but a hole in certainty itself. The universe we know may be one thread woven among many. Each black hole then is a knot where threads cross, where many tapestries of reality touch. The idea is dizzying, yet it offers a strange comfort. If our universe ends, perhaps others continue. If our path closes, perhaps others remain open. And so black holes may not be single doors at all. They may be many doors opening into countless stories, all unfolding at once, forever. Journeys where time itself flows differently. Inside or around a black hole, time no longer follows our familiar rhythm. It stretches, slows, folds. For an observer outside, the fall seems frozen. For the one falling, it feels normal. But if black holes are gateways, then inside, time may flow differently altogether. What feels like a moment outside might become centuries within. Or what feels like centuries may pass as moments beyond the veil. Black holes could be corridors not just through space, but through time. Imagine stepping into such a journey. You could emerge not in another place, but in another era, far in the future, or perhaps in the ancient past. Time becomes elastic, shaped not by clocks, but by gravity. Black holes may be nature's time machines, their corridors twisting not only where we are, but when we are. The bending of time also suggests something deeper. Perhaps black holes do not erase the past or the future. Perhaps they fold them together. Inside, time may exist all at once, every moment overlapping. To cross the horizon might be to step into eternity, to see all times as one continuous flow. This vision is not only scientific, it is spiritual. We often dream of transcending time, of seeing life as more than fleeting moments. Black holes hint that the universe itself already holds such places where time is not lost but transformed, where beginnings and endings blur into one river. And so when we think of journeys through black holes, we may not be imagining only travel through space. We may be imagining the first true voyages through the many shapes of time itself, steps into futures we cannot measure. If black holes bend time, then stepping close to one might mean stepping into the future. A spaceship orbiting near the horizon could experience only a few hours, while outside thousands of years pass. For travelers, the future would arrive not by waiting, but by gravity. Black holes become staircases into time, letting us climb into futures we cannot measure. This possibility is less fantasy than fact. Relativity already proves that time moves differently in strong gravity. Black holes are simply the most extreme examples. To use them as gateways into the future is not beyond physics. It is written in the physics we already trust. Imagine what this means. Civilizations could wait near a black hole and emerge to find the universe transformed. Stars shifted, galaxies changed, histories rewritten. The future would not be distant, it would be a horizon away. The black hole becomes less of a trap, more of a time bridge waiting for the daring to cross. But the cost is high. To leave behind the present is also to leave behind everything you know. Loved ones, cultures, entire worlds would pass away in your absence. The journey into the future would be both a gift and a sacrifice. Black holes remind us that time travel is not just physics. It is also longing, loss, and choice. And so black holes whisper of futures we cannot measure. They show us that time is not fixed, that stepping closer to their shadow is also stepping closer to tomorrow's secrets. The past preserved in unreachable light. Black holes not only shape the future, they also trap the past. Light that falls near the horizon never escapes, but it lingers, stretched and frozen. To a distant observer, this light seems suspended, never quite falling in. It is as if the past itself is preserved, locked at the edge of the black hole forever. Every star that fell in, every particle of matter, leaves behind a frozen shadow of its final moment. This frozen light becomes a kind of museum. To look near a black hole is to glimpse the past etched in unreachable glow. The information may be scrambled, stretched, distorted, but it remains. In this way, black holes hold on to history even as they pull it inward. They do not erase instantly, they preserve, even in their silence. The thought is both eerie and comforting. It means that no event is ever truly gone. Its light, even if trapped, still exists, still marks the universe. Black holes, then, are not just doors into the unknown. They are archives of time itself, holding past moments in their invisible embrace. Scientists often call this paradoxical, the past preserved at the horizon, yet unreachable. To us, it is a reminder that memory is not always accessible, but it is never absent. The black hole may hold on to its past like a diary written in a language we cannot yet translate, and so the black hole becomes a strange kind of mirror. It shows us that the past is not destroyed, it is preserved, unreachable yet real. A reminder that nothing is ever truly lost, only held in ways we do not yet understand.